Hello Math130 students, we are going to pick up on page 5, section 4.2. So now in this section we're going to be adding and subtracting polynomials, and we're also going to learn some definitions. So the first definition I want you guys to learn is going to be terms. So terms in a polynomial are separated by addition and subtraction. So let's say I have 3x squared minus 2x plus 7. So here, if we count our addition and subtraction, how many terms will you have? We have 1, 2, 3 terms. So this is a term, this is a term, and this is a term. So how many terms do we have? Well, we have 1, 2, 3 terms. So since we have 3 terms, a 3-term polynomial is called a trinomial, okay? Or if it was a monomial, that means there wasn't anything that's being added or subtracted. A binomial, that means 2 terms that are being added or subtracted. And polynomial is really just general for anything, right? So either 1, 2, 3, or more than 3. Usually say polynomial for something that's more than 3. And also we have the degree. So if we have the degree of a polynomial, it is the highest exponent or power of any term. If one single term has several exponents, then the powers are added to make up the power of the term. So let's look at some examples below. It says, for part A, determine whether it is a monomial, binomial, trinomial, or other polynomial. And part B, determine the degree of a polynomial. So you're just like, okay, well, let's see how many terms this first one is. So let's think about the terms. That's going to be our part A, right? How many terms is going to tell us whether it's a monomial, binomial, trinomial, or just a regular polynomial. So here, let's look at our addition and our subtraction. So it tells us we have 1, 2, 3, 4 terms. So since this is 4 terms, then we are going to say that this is going to be a polynomial or other polynomial. And then for our part B, it wants us to find the degree of the polynomial. So part B, if I'm thinking about the degree, well, remember, it's going to be the highest term or the highest exponent in any given term. So let's think about this. If I'm looking at this polynomial, the thing that I want to be focusing on is going to be the exponents. So here we have the exponent 2, 6, and this actually has a 1 on it, right? So those exponents, the highest one is this one, and the exponent here is going to be 6. So our degree is going to be 6. It's the highest exponent of any given term. Okay, so now let's look at number 2. So looking at number 2, well, let's see how many things are being added and subtracted. So that's going to give us the amount of terms. So the amount of terms, we have 1, 2 things that are being separated by addition. So we have 2 terms. So because we have 2 terms, that's going to be a binomial. So now for part B, we're going to be looking at the degree. So if I'm looking at the degree, remember, I'm going to look at each term. So I have a term here and I have a term here. Now what's different in this scenario is that now we have 4 and 2, right? We have 2 exponents in one term. Same thing with that term. So what we're going to do here to figure out the exponent, we are going to add 4 plus 2. That's going to give us 6. And in this term, same thing. We're going to add up the exponents. So 5 plus 3 is going to give me 8. So our degree here is going to be 8. because 8 is definitely bigger than 6. Remember, the degree is the biggest exponent of any given term. And here I have two terms, which is a binomial. Okay, well, I hope this is making sense. Now, for our next example, it says evaluate the polynomial at a given value. So what is this exactly saying? So we have a function g, which is just 5x minus 3. So that find g of 4, what does that represent? Well, this is actually saying that 4 is equal to x, so find my y value. And don't forget that your y value is the same as my g of x. Those two are equivalent. So y is the same as g of x. It just means, hey, remember that y equals mx plus b? Well, if it's a function, meaning it passes the vertical line test, then it's definitely going to be a function, so they happen to call this function g. So let's see what's going on. So we have our g of x, our function, is equal to 5x minus 3, which is the same as saying y is equal to 5x minus 3. Now that g of 4, it says plug that x is equal to 4 into that equation. So y is equal to 5. I have my x value minus 3. And that x value that I'm plugging in is 4. So now I have y is equal to 20 minus 3, which is going to give you a 17. So now that you know that y is equal to 17, you want to make sure that you answer the question correctly. So here you're going to say that g of 4 is equal to 17. And if you're like just wondering, well, what does this really mean? What this means is that when x is equal to 4, then my y value is equal to 17 for the function g of x is equal to 5x minus 3. Now you don't have to write all that, but I just wanted to kind of give you a heads up on what does that actually really mean. We get so mechanical in math that we forget what we're actually really communicating. And this is what we're communicating. We're communicating when x is equal to 4, that's the value that I plugged into the equation, then the y value that I got out was 17. So now using our vocabulary and our description, we are going to say that the function, g of 4 is equal to 17, meaning that the function g of x, 5x minus 3, when we plug in a 4, we get a 17. So however you want to say that, that's what that g of 4 equal to 17 actually means. So we can do that with example number 2 as well. So here, this is telling us that we have our function f, okay? So we're going to let our x value equal to negative 1, so we are going to have to find our y value. So we have that y is equal to a negative 8x squared plus 6x minus 6. And we are going to let x is equal to negative 1. So then y is equal to a negative 8 plus 6 minus 6. And notice how I put parentheses every time I want to plug in a value. So that value that I'm plugging in is a negative 1. Now I'm just going to plug this into my calculator. So negative 8 times a negative 1 inside parentheses plus 6 times negative 1 minus 6 gives me a negative 20. So making sure that we use our vocabulary as what was given to us, right? It said find f of negative 1. So you have to answer that question. So you can say that f of negative 1 is equal to a negative 20. And that's going to be your answer. So we're going to take that same idea and apply it to number 3, except we're just going to wrap it up in a word problem. So if you know how to do this problem, you can do this word problem. So it says the height of a plant in inches p after planting it is given by the polynomial function r of p. Find the height of the plant when p is equal to 90 years old. So you're just like, okay, well, they give me this equation. The equation is r of p equal to a negative 2p squared plus 270p. So that equation, or that function, was given to you here. And it says to find the height. So let's say height is h. So they want you to find h when p is equal to 90. So they want you to say p is equal to 90. And so the height is what you're kind of trying to find. So that's going to be your r of p. So you can say that your r of p is equal to your height. So I have my height is equal to a negative 2 times p squared plus 270 times p. So that, remember, the value that they gave you was p is equal to 90. So 90 is what you're going to plug in into those parentheses. So I have a negative 2 times my 90 squared plus 270 times my 90. So then your height is equal to 8100. So 8,100. So that's going to be the height. And remember here, the height is given to you in inches. So we're going to say that the height is equal to 8,100 inches. So after 90 years, that's how high the plant is going to be, which is a very tall plant, I guess. Okay. Now, for the second part of this section, we are going to be adding and subtracting polynomials. So to add and subtract polynomials, remember these are terms that are separated by addition and subtraction. So it really kind of boils down to two main steps, which is remove the parentheses and combine like terms. So each problem is going to be unique because you're going to add or subtract or multiply or divide by unique numbers. But really, you're just trying to remove the parentheses, so distribute really, and then combine like terms. So let's look at example number 1. So I have my function f of x, and I have my function g of x, and I want to find the following. So f plus g of x. So that's going to be my part A. So this is the addition of the polynomials. So I'm going to say addition of both functions. My f of x and my g of x. So for part A, I'm going to add my two functions together. So I have my f of x and I have my g of x. So what we're saying is that I'm going to have my f, color coordinate here, f of x plus my g of x. So I'm just adding these two functions together. So my f function is 9x squared plus 8x plus 2. And I'm adding to it my g function, which is that 4x squared. So here, do I have any like terms? Yeah. This 4x squared and this 4x squared are like terms. So I'm going to add those together. So if I have 9 plus 4, that's going to give me a 13x squared. And everything else isn't, you can't combine. So I'm going to have a positive 8x and a positive 2. So now I can say that f plus g of x is equal to 13x squared plus 8x plus 2 as my final answer. And now for part B, it says, hey, remember that those two functions when you added them together, the f plus g, now do it evaluating at -2. So this is saying, hey, f plus x plus g of x, and it's saying let my x value equal to a negative 2. Well, you already did the f plus g of x. You did that in part A. Remember, you added f of x plus g of x. So when you did that f plus g of x, when you added those two functions together, you got a 13x squared plus an 8x plus 2. So now it tells you to evaluate when x is equal to negative 2. So, okay, I have my 13 plus my 8 plus 2. And that value that you're plugging in is going to be a negative 2. So then from here, you just plug that into your calculator. So 13 negative 2 squared plus 8 times negative 2 plus 2 is going to equal to 38. So then from here, I can say that my f plus g of negative 2 is equal to my 38. And that's going to be my final answer. So let's go ahead and take another look, just in case you guys need another example. So here we're going to do the same thing. We have two different functions, f and g. And now we want to do the subtraction with respect to x. So for my part A, I'm going to have my f of x being subtracted by my g of x, okay? So let's call my f of x the blue equation and the purple equation for my g of x. So now I know what I'm plugging in. So my f of x function was a negative 9x squared minus 2x. Now I'm like, oh yeah, okay, this is subtraction. So I want to be careful. I want to remember that it's subtract the entire function. So I'm going to go ahead and put subtraction, and I'm going to have my bracket. So that way I know I'm going to distribute that negative into everything. So that function g of x was a negative 3x squared plus 6x minus 9. And you can think of it as a negative 1 that's going to be distributed to everything. So now I have a negative 9x squared minus 2x. And now because you distribute that negative into everything, a positive 3x squared minus 6x plus 9. So when you combine like terms, which is your second step, you have a negative 9x squared plus 3x squared. They have the same exponent, so those are like terms. And when I do that, I get a negative 6x squared. And I also have a negative 2x, a negative 6x. So adding those two together, because those are like terms, so negative 2 minus 6 is going to give you a negative 8x. And you still have a plus 9. So now for your final answer, the way you're going to write it is f minus g with respect to x is equal to a negative 6x squared minus 8x plus 9. And so that's going to be your final answer. Now for part B, what this is saying f of x plus g of x, and let your x value equal to a negative 4. So, okay, I'm going to have my f function, which is a negative 9x squared minus 2x. It's being added to my purple function, my g of x, which is a negative 3x squared plus 6x minus 9. So when I add those together, my like terms here, so negative 9 and my negative 3 is going to give me a negative 12x squared. I also have negative 2 and a positive 6, so 6 minus 2 is going to give you a positive 4x, and you still have a negative 9. And don't forget that you want to now let x equal to a -4. So you have a -12 x squared plus 4 minus 9. So what you're plugging in is a -4 into those parentheses. So you grab your calculator, -12 times a -4 squared plus 4 times a -4 minus 9 is going to give you -217. So now you can say that f plus g of -4 is equal to -217. So notice how in part A it was about the subtraction, and in part B it was about the addition and letting the value x equal to -4. Okay, and that is all that we have for this section. If you guys have any questions, please feel free to email me or the Math Success Center for tutoring, and of course our wonderful tutor that we have assigned for this class. Okay, thank you guys.